Let's have a look at these then. They're really difficult problems, but we'll see if we can get them in principle. I'm not going to worry about the algebra. I'm just going to try and get the principle of the problem using the process of differentiation. So here we've got something to the half, haven't we? So dy dx then. Something to the half, u to the half is a half of the something, so minus a half, and that something is this, multiplied by the something differentiated. Now this something, when we differentiate, is a quotient, isn't it? So it'd be v, use the quotient rule, times du dx, minus u, more than one term per the bracket, times dv dx, that's a minus 1, all over v squared, that thing squared, isn't it? And we could tidy that up. For example, the top is 1 minus x, 1 plus x, so that would just be a 2, and that would cancel with that 2. So it can be tidied up. Well, let's tidy up the first one, but I'm not going to worry about the rest. This is a 2, we just said that, haven't we? Okay, and that will cancel with that 2, and then this would be 1 plus x to the minus a half on top, and then this would be 1 minus x to the minus half, and then you've got a 2, so times you add, so you'd get 1 minus x to the 3 over 2. So we've tidied up the first one, but in general I'm not going to do that. So let's move on. Something to the 5u to the 5, yeah? So dy dx is 5u to the 4 multiplied by the something differentiated, isn't it? Now the something is a quotient v, which is 1 plus x, times du, which is 1, minus u, times dv, which is 1, over v squared, 1 plus x squared. There we are. So again, I'm tempted to tidy this up. This is 5x to the 4 over 1 plus x to the 4 times by, we've got 1 plus x here minus x, that's just 1 on the top here, isn't it? So we got times by 1 over 1 plus x squared. So it's 5x to the 4 over 1 plus x to the 6. So that wasn't too bad. Next one. Let's have a look at this. Then we've got a quotient here, and the top part of the quotient is itself a product. So dy dx then. Quotient rule v times du dx minus u times dv dx, which is 1, all over v squared. V du dx minus u dv dx all over v squared. There we go. So it was v du dx. This part here is the derivative of this product. This is a product, so it's u dv dx, e to the x goes to e to the x, plus v e to the x times du dx 1. And again, we could tidy that up with the algebra, couldn't we? But I'm not going to do that now. I've just shown you the principle of how to get it, and then you just tidy it up and simplify where possible. Now this is another nasty problem. Let's have a go at this one. Okay, so it's a quotient, isn't it? So it'd be v times du dx, v du dx, bit more room, minus u, there's u, times dv dx, and I'm going to do dv dx because it's something cubed. U cubed is 3 times u squared multiplied by that something differentiated. So that was v du dx minus u dv dx over the v squared. This squared will be power 6. So the only thing to put in was v du dx. So I have to put in du dx. So that's this part differentiated, which is u, because it's a product rule, times dv. And this part here is a function of a function, plus v times du, 3x squared. So that part was u dv, differentiating this to the half. Let me just give a bit more room. So let's do that part then. It was, what was it, u dv, differentiating this to the half, u to the half. Well, it would be a half u to the minus a half, wouldn't it? A half u to the minus a half, multiplied by the something differentiated, which is 1. And there it is there. It would all need tidying up and simplifying, probably. And you could try and get the answer there. Let's turn our attention to the last problem. So I'm going to give ourselves a bit more room. And look at this one. Okay. Let's have a look at this one then. We've got something to the half. So dy dx will be something to the half. U to the half is a half of the u to the minus a half. That u is this stuff in here, isn't it? Multiplied by, that's something differentiated. And that would be a quotient, wouldn't it, in the first instance? So that would be v times du dx minus u times dv dx, 3, all over, because it was a quotient, it was v du dx minus u dv dx, all over v squared. And this is the v in question, isn't it? 3x plus 2 squared. Pretty horrendous problem. So we did a v du dx minus u dv dx over v squared. The reason I put a question mark here, v du dx, is because this is a product. See it? So this part is that differentiated. And in that case, we've got a product, so it's u times dv dx, 1, plus v times du dx, 1. Close that bracket. So if you want to work that out, best of luck. If you get it right, well done. And you can tidy it up bit by bit as you go. But that's an algebraic problem, really, not a problem in differentiation.